Hello everyone and thank you for watching this live event, lesson number 13 from the Spring Fundamentals stream, and we will discuss about the basic contracts in Spring Security. So about Spring Security, we will only deal here with the basic contracts, but you will already find on the same channel a lot of information about Spring Security. It is a separate playlist where you can find a lot of more details, and where I will actually even add more videos in the near future. But I wanted to add this lesson also to the fundamentals stream because, well, you see, Spring Security is really important and you at least have to be aware about Spring Security. So even if you don't plan to go into details with Spring Security, thing that you can do by watching the videos in the Spring Security playlist, you still have to understand the basics to be aware of Spring Security when you work with Spring. If you are watching the event live, don't forget that I have a live chat there, so you can send me the questions, and I always keep an eye on the live chat. And if you are watching the event recorded afterwards, you can leave me the questions in the comments section, or you can find me on LinkedIn and Twitter and you can ask me the questions and I will create separate videos to answer you. Now let's try to start with a project and see what happens. We will discuss about user details, user detail service, and the password encoder. Really important stuff, as I've said, at least to be aware of if you are working with Spring. And again, if you want more details, don't forget that there is a Spring Security playlist on the channel where you can find a lot more details and where I will add a lot more videos about all the details that you might need whenever you develop applications and systems with Spring and Spring Security in a real life scenario. We will create a Spring Boot application with Spring Initializer, version 12, Java, and just a group ID for my Maven project. And then that will be Spring Framework E13, and again I will use Java 12. And the only things that I actually want to add is the Spring Web Starter, because I will create some REST endpoints that I want to secure while I will prove you the basics about Spring Security, and of course the security dependency, because that's actually what I'm talking about at the moment. And you can see the Spring Boot version, which is 2.1.7, so I think it just changed this week and we have a new version, so I will always use the newest version. That's why you will see me now using 2.1.7 at this time. And we will create now the project. Let's see what has to be done and what should we expect from the beginning. And the first thing I will actually do is create an endpoint for test, and I want to see which is the behavior that my Spring Boot application has when I have a very basic endpoint, only by adding the dependency of Spring Security to my project. And by the way, if you are going to the POM.xml file here, you will actually see that beside the fact that I use the 2.1.7 version of Spring Boot, I have added the dependencies, the following dependencies, to my application, and they are the Spring Boot Starter Security and of course the Spring Boot Starter Web. And I won't discuss actually the last two because they are only unit and integration test dependent, and these will be discussed in one of the future lessons. So for the moment, you can just consider that the only two important dependencies that I have and that I use in my project are these two here, the Spring Boot Starter Security and the Spring Boot Starter Web. So as I've said, I will start with developing a small endpoint, a small REST endpoint to prove the default behavior of my project, and then I will have to override the default behavior by working with the basic Spring Security contracts. So let's see, let's just create a new package which will be controllers in my case, and in which of course I will add the hello controller class. Hello controller will be the name, and then in order to be a REST controller, of course I have to annotate it with REST controller, and I will have to add an endpoint like public string hello, and the only thing of course that my endpoint will do will actually be to return hello. So not a lot of functionality in this application. The only important thing we are just facing now is how Spring Security works. So I just have a very simple endpoint to prove that. And you already know that if at this moment I would actually start my application, you would expect me to be able to call this endpoint without any problem, but this will not happen. And the reason for why this will not happen is actually because I have this Spring Security dependency that will make our Spring Boot application to create some default configuration. You know, this is the behavior of Spring Boot. It creates auto configuration about default configuration about around the dependencies that you add in your project. So in this case, because of my Spring Security dependency, you will actually have default components added to the context, and that will make that this endpoint actually by default is secured. And how is it secured? By using the default username and password. To prove that, let's simply just run our application and observe some of the things, including what happens when you call the endpoint itself. So only one application with a controller class with an endpoint hello, very simple. And in spite of fact that we didn't do anything about security itself, our application is secured. And the first thing actually that I would like you to observe is this row in the console. You see that a row appeared. You didn't see this in the previous lectures. And that's because this is actually printed out by the configuration that we have default provided us by Spring Boot. And in this case it's telling you that a password is, and the value of the password given as a unique identifier here, and that is the password actually of the user that exists in your context. By default you have a user in this context, and this endpoint can be accessed by that user, and that user has this password that will actually change every time you restart your application. And this is kind of a hello world that proves you when you use a Spring Boot application together with Spring Security, it proves you that Spring Security really works. So let's simply take this password, and I will open a Postman, and I will try to call my application, my endpoint. So that would be http localhost 8080 hello, and I will try to call the endpoint using Postman, and of course I will get back an 401 unauthorized, which is not the behavior that you would have gotten in case you would have used a project that didn't have the Spring Security dependencies. So the fault here, let's call it the fault for why we receive a 401 as a code, is simply because of the dependency that we have added in our POM XML, and that makes us to be needed to use the authentication. So by default we will actually use a basic HTTP authentication, and then you will have to write a user and the password, and the user is actually user, and the password is what you have copy pasted from your console. Make sure that you don't have spaces or something here, and then when you send the request you will actually get back the hello. That means that your user was authenticated and authorized to call the endpoint, and this is the default behavior of running a Spring Boot application with Spring Security without doing yourself any kind of configuration. But of course this doesn't make make us happy a lot, just because in a real case scenario you don't have simply a user with an every time generated password at the start of the application and you use that user. You will need the possibility to configure your own users, and in order to do that we will create the configuration class. So in my case, as you are already used, I will create a config package, and inside the config package I will create the project config class. Let's call it project config, and of course to make it a configuration class, you know that I have to annotate it with @configuration. So now it is a configuration class, and that will allow me to specify beans within it. In my case, the first bean that I would like to define is the bean that is called of the contract user details service. So the three important contracts that I would like to discuss during this short lesson is user details service, and then we will have also a short discussion about user details manager, which you will see is only an interface segregation, but basically user details service is what is important in terms of authentication for Spring security. And then of course we will have to define our password encoder. So password encoder, that is really important because it's the object that deals with the hashing of the password and the matching of the password whenever a new password is sent for authentication purpose. And first thing that I want to do is, of course, as I have said, to put a bean of type user details service in the context. So user details, in terms of interfaces, of contracts, of basic contracts used by Spring Security, is that contract that defines the user. I know that is called user details. Maybe for some of you this would look like a strange name. Why is this details here? But it's actually the user. So the user that has as attributes especially the username, the password, and a list of authorities, which actually mean what is the user able to do in our application. We won't get into a lot of details because it's only a short lesson. If you want more details, again, go to that Spring Security playlist. But as an idea, this is the user details, which represent the user. And then we have the user details service, and this service here is exactly what tells you what exactly this contract, the meaning of this contract, that is the contract that is used in order to retrieve the users. So inside this user details service you will find one and only one abstract method, which is load user by username. So this is the object that is used by Spring Security to load your user from somewhere. That somewhere can be, for example, the in-memory of the application, or it can be a file, or it can be a database, or it can be a web service, or it can even be, I don't know, a socket or something that allows us to access a network service like an LDAP or an Active Directory and so on. So that's why we really need to define the user details service, because this is actually the bean that Spring will use to load the user. So this is where the user will be loaded in your application from, the user details service. This is the contract that you will implement, and you will, by implementing it, deliver the logic for Spring to load the users. And then you have the password encoder, because usually every time in real life scenarios, the password will not be provided in plain text. In our examples, we usually do that to save time, and I have a separate video in which I explain the password encoder. But usually the password encoder has these two behaviors, which one of them is to encrypt the password, hash it somehow, for example by using bcrypt, and then matching a password on a specific encryption to see that the password is or not the one that generated that kind of encryption. So it will allow us to see if a password is correct or not in this way. And as I've said, let's just start by defining in the context our user details service, user details service, and to be a bin in the context, of course, I have to add the @bin annotation, and then I will have to specify an implementation. So this is only an interface, and if you go in the interface itself, you will see the declaration. That is the only method, I have already told you about. The parameter here is the username, and then it has to return a user details that I've said a little bit earlier that represents the user in Spring Security. So it is that method called by Spring Security with a provided username to get back a user. And if the user doesn't exist, the method should throw this username not found exception. And then if the user exists, it should return that user under the contract of user details. And if you go here, you will see that the user details, as I have said, is the contract representing the user, which you will see will have a username, a password, and a set of authorities. Is actually given as a collection here of authorities, and an authority is nothing more than a permission a permission of an action that the user can do. So the interface that represents this authority is called granted authority, and you will see that the only thing that this interface has is a name, in our case in the interface, of course, represented by this abstract method getAuthority returning a string. But you have to remember the user has a username, password, and a collection of authorities representing the actions that the user can do in your system. And then you will see 4 other methods here that are simply used to define if you want the user to be able to be locked in your system, or to be enabled or disabled, or to expire the credentials. That's details that you might use or not, depending on how complex your system, your application is. So this is what I need to implement, and I have multiple options. I can use an already provided implementation by Spring Security, or I can define my own implementation, and usually maybe in a real life scenario you would have to create your own implementation, because usually applications are very different one from each other, and you don't necessarily just use a database. Maybe you can have a more complex situation, and then you have to implement your own user details service. But to spare time in this case, I will simply use here an already provided implementation of the user details service, which is called in-memory user details manager. So this is my declaration here: in-memory user details manager, and new in-memory user details manager. And this is exactly what I will return. And if you go inside the class in-memory user details manager, you will see that the class directly inherits the user details manager interface. So it's not implementing directly the user details service. And this is the 4th interface actually that I have written here. The user details manager is actually inheriting the user details service. So the reason for why here I am allowed to return this manager of type user in-memory user details manager is actually because the user details service is inherited by the user details manager interface, which then is implemented by this class. And maybe you will see it even better if I use the var word here to make the syntax shorter. So going one level up, you will see that user details manager extends the user details service interface and simply adds a little bit more methods to that one abstract method of the user details service. And it's called a manager actually because it allows you to manage the users. So not only to get the user out of somewhere, but also to create a user, update a user, delete a user, change the password of the user, and be able to see if a user exists or not. And these methods, this group of 5 methods, are considered the responsibility of a user details manager, which is also a user details service by inheritance. So if you want only to provide Spring Security with an implementation that will allow Spring Security to find your user, then you don't have to implement the user details manager. The only implementation that you need is the user details service. But if you want in your application to also be able to create user, update user, delete user, change password of the users, or see if the user exists or not, then you will have to implement the user details manager that comes, as you can see, with a little bit more responsibility as a contract. So this is a really nice example of interface segregation from the solid principles that is proven here by the Spring Security implementation. Very nice architecture that was created here by these guys. So now we know that actually by using this implementation called in-memory user details manager, we will be able to provide Spring Security with users. And the reason for why it's called an in-memory user details manager, of course, is because the users are kept in memory. Now we also have a very easy possibility to create users, and that's a builder, a known builder that we can use to fastly create our users that we will also add to the in-memory user details manager. But generally you have to understand that the users probably will come from somewhere. So in my example here, to spare time, I will just put them in code, which is only for a theoretical example that will only work in case of a theoretical example like this one in a course, but it will never work for a real case scenario. Let's try to do so. Just try to create a first user, and then we have the user class, and this is actually a builder, and you can see, say for example, we have the user with username Bill, and then we have to provide it a password as well, and then you can provide them granted authorities or roles, whichever you want. For example, we can say that this is an admin, and we can say that I don't know, it has some authorities like the write and the read authority. And from now on you understand that you can configure your user like that by using this builder. In the end, I should also call the build method in order to have a user details, and then I can just create a second user that will be U2, and this will be, for example, John, and this will be a manager, and the manager can only read, for example. And then I will just being a user details manager to create the user, so to add the user to the in-memory collection of users managed by this in-memory user details manager. Of course, I will have to call the method that is declared by the contract, which you have seen previously a little bit, and that you know now. It is called create user. So I have to create the user U1 and the second user as well. And now I actually have a user details service, and I have 2 users. This var word here is not satisfying me from the fact that you now can't see actually that this really is a user detail. So for this example, I would really like to replace this with the type itself. I want you to see explicitly here that this really is a user details, and this is really important because again, user details is the contract that is understood by Spring Security. So if you have a user but you don't expose it as a user details contract, it can't be used with Spring Security. If you want to tell Spring Security this is your user, you need an implementation of this user details interface. Otherwise, you can't make the link between the framework and your user. So let's say maybe you have a user that is a normal DTO, or maybe it's an entity in JPA. What should you do? You have multiple options. You can maybe implement the user details directly in that class. Sometimes this is not considered really clean because it might mix some responsibilities, and again, we would like to respect the solid principles and we would like to have a single responsibility. But you can also create a decorator again on your entity, and then you can decorate your entity with the implementation of user details, and this maybe would be a cleaner solution because it decouples your responsibilities as well, and that should actually create more maintainable code. Good. But for the moment, important is to understand the purpose of each of these contracts. That's what I try to explain you here. And if you are trying now to rerun your application, this will still not work. And the reason for why this is not working is because you have, as you can see here, provided a password that is encrypted somehow. Not in our case, of course, you can see it in plain text, but usually it would be stored somewhere encrypted. We can suppose it is. And always Spring Security believes that the password is encrypted, so we'll look for a password encoder. The password encoder is that object that will be used by Spring Security to be able to match your password above an encryption. So if you don't have a password encoder, Spring Security will crash with an exception telling you, I don't have what I need to be able to identify if this password is correct or not. And it was made so that it never expects to have passwords in plain text like this, which is really basic. You anyway would never want passwords in plain text in an application. So that's why, for example, if I now have only rerun my application and I will actually try to use one of the users, like Bill, for example, 12345 was the correct password, then I should still get a 401 unauthorized, which really is my case. And if I go back to my IntelliJ here, I should even have an exception that will allow me to understand what the problem is. So if I just go up to my to the message of the exception, you will see that I have this illegal argument exception, but the message is more important. It tells you there is no password encoder mapped for ID null, which should allow you understand that what the problem is. So the problem is that actually Spring Security is looking for a password encoder, but it doesn't have a password encoder. Another important thing that I would like you to observe by simply just rerunning the application, I will do that again. I would like you to see that despite the execution that we have done in the first time with this project, where you had that row we have even used with the password, the default password of the user was in the console, but now after I have added my own user detail service, you won't see anymore that row in your console, and that's because the row that you have seen in the first execution of our application was actually caused by the implementation of user detail service that was the default in my context of the Spring Boot application before creating my own bean. So now that I have created my own user detail service bean, it has overridden the bean, the pre-configured bean, and it is this one now that is used actually instead of the one that that was previously used. So now what should we do to make our application work? Very easy. Just define a password encoder. So what kind of password encoder should we define in this case? Well, we should have a password encoder that doesn't do any encoding, because it's a plain text, and usually, as I've said, we won't use that in a real case scenario, but in our demo here we have really used a plain text just to be easier to read, and we have to use a password encoder that doesn't actually encode anything and simply uses an equals in order to match the passwords. And it really exists. There is an implementation for this password encoder, but it also, the class is marked as deprecated, such that you can see that you won't use and you don't want to use something like this in a real life application. So if you just want to create a proof of concept or a very short demo example, just to test something, and you don't want to lose a lot of time into implementing your own user detail service and so on, and you just allow the passwords to be plain text because you will never use that application somewhere, you just want to test your knowledge, or maybe you just want to learn something new, then you can use the no-op password encoder. So you just have to add the password encoder into your context by creating this method that returns the password encoder, and of course annotating it with @bean. And the implementation of password encoder that I will return is this no-op password encoder, and it's this design as a singleton. If you go inside the no-op password encoder, but let's first go and see what is the definition of the contract, and then we will go inside the no-op password encoder to see how is it implemented. So why by using this password encoder we can actually use passwords in plain text. So if you go into this contract as well, you will see that it actually defines is 3 methods, but 2 of them are the abstract ones. The other one is just has a default implementation. So most probably if you create your own implementation of password encoder, you won't override it. You will just override it in specific situations. But the most important methods here are actually the encode method and the matches method. So the encode method receives a string as a parameter and returns the string encoded. And when I say encoded, it means it actually creates a hash or something out of your password in order to not be able to transform back the result into the input. So that's really important when you deal with passwords. Use such an algorithm that doesn't allow you to obtain the input from the output. It should be only one way. You should be able to obtain an encrypted output, a hash, how we call it, but you shouldn't be able to turn it back. It's really important. And then in order to match password upon an encryption, this matches password is the implementation that you have to do to specify what should you do to match a password on a given encryption, and it would return you true or false, which would be true if the password really is the input that was generating that output. So it matches on the output, it matches on the encryption, or false, of course, if the password is not correct, if it's not that input that provided the expected output. So these are the important 2 methods of the password encoder, and that's, if you go now to this implementation that we have used here, which is the no-op password encoder, you will actually see that the encode and the matches methods really just deal with plain text. That's why we are using them in this demo example. You can see that it's simply just returning the string as a string, the password, so it doesn't do anything, it doesn't change it at all. And then the matches is only an equals, so it simply applies equals between the strings. That's exactly what should happen if we are working with plain passwords, the way we are doing here. But in a real life scenario, you wouldn't use something like this. Probably you do use something like bcrypt password encoder or something like this. So you would really use an encryption algorithm, a hashing algorithm, to make sure that your passwords can't be stolen or they can't be reversed somehow by somebody who has access to them, which is really important from multiple points of view, starting from security and ending with morality. Okay, now if I have added this password encoder, mostly the job is done. I will restart again the application. I have a password encoder, so I have provided Spring Security with the possibility to test the password. I have provided Spring Security with a user details service, that is the possibility to find the users. In my case, I have simply added 2 users in memory, which are represented by the user details contract. So these are the 3 really important contracts that you first of all need to understand when discussing about Spring Security. And the 4th contract that you have seen that you have seen in this video, in this lesson, is the user details manager, that is actually adding more behavior to the user details service. So it's extending the user details service and adding about 5 more methods to that contract. And I've also said about this that it is a really nice example of interface segregation and a really nice example of a really well done architecture. So I have restarted my application, and now I'm going back to the Postman, where I will call the endpoint, and you will see now by using Bill and 12345 or John with the same password. In my case, I will actually be able with both these users to call the endpoint. So this is how I have implemented my user details service in order to have my own users, and I have provided Spring Security with the users and the details about the users who can access my endpoints. Now, this is not enough, because usually beside that you also want to configure which are the endpoints that will be accessed and by whom. So the last thing that the last chapter that I want to discuss in this introduction to the basic contracts of Spring Security is the implementation of Web Security Configurer Adapter in order to specify which endpoints can be called and by whom. So this is at least the will create a complete image of the basics of Spring Security that should allow you to start learning from now on more details about this really important framework. So the last thing in any project I would actually have to do would be to specify which endpoints are secured. In my case, yes, I know I only have one endpoint, but imagine a real application. In a real application, we will for sure have multiple endpoints, and then you will have situations in which some endpoints can be accessed by any user without having any credentials. Some endpoints would be just accessed by all the users that are authenticated, and there are also probably situations in which you just have a specific user or a specific user having a specific role or authority that can call a specific endpoint. So there are configurations done at the endpoint level, and in a real life scenario you can't escape that. You just can't simply like in my case here authenticate any endpoint. You will have different configurations based on the endpoints. So let's see how is this done. Is by extending the web security configurer adapter class in the configuration class, and then you will be able to override the configure method. So this is exactly what I will be doing now. I'm overriding this configure method here with the HTTP security as a parameter, and then by doing that I will be able to simply specify the configuration, like for example what kind of authentication am I using, HTTP basic, and who I'm actually who I'm actually authenticating for which endpoint. For example, I can specify something like authorized requests, and then I need a matcher, and the easiest is any request, and then I can say for example authenticated. And by adding this method like this I will actually change nothing about my about the way my endpoint will work, because this is exactly what was happening without adding this method. By default all the requests are authenticated. But now that I know I can do this, you also know that you have the opportunity to change the configuration. You can even say something like I want all the requests to be permitted. Again, usually if you are using Spring Security, you would like that at least some of your endpoints are authenticated. You can permit all of any request, but you can and you will probably in a real case scenario just specify the permission to some of them, and you will still keep the authentication for others. And in order to do that, for example, you would actually rather say something like I want to use an AND matcher which will allow me to specify an expression that matches on a group of endpoints, and in which I can specify also the HTTP method. For example, if I want to secure only the get calls, or only the post calls, or only the put calls, or only the delete calls. Or maybe I want to only configure authentication on a specific URL type. Doesn't matter which HTTP method I would use, so all the methods and the specific URL, or I can mix this together. So in my case, for example, let's say that I just say use authenticate all the gets, and that would be get authenticated, and then all the others, that would be any other request will be permitted. So that would mean in my case only secure the get calls, and if you have any other kind of a call you can use it without having a user and a password. Or you can say something, if you want to call the get, you have to have the role admin. So that would be done something like this. I would have the role, oops, it should be a string here, so it has role, or has any role if you want multiple admin. So that means if you have a get, all the get calls can be called only if you are an admin. And then I can use another end matcher where I will say if you have a post, then you can call it only if you are a manager. And I just took this because these are actually the roles that I have used in my case, admin and manager here. And by the way, that should be prefixed with role, but that's another thing. I don't want to get into more details with this now. And just to show you, yeah, what kind of configuration can you actually do here. So you can configure who is accessed by which kind of configuration. So I just said here all the get calls, in order to call an endpoint that is exposed by the HTTP method get, you have to be an admin. If you are now using a user that is not an admin, you won't be able to call the get endpoint. And then I said, and continuing, all the posts can be called only if you are a manager. And then all the other requests can be called without needing any kind of authentication. This configuration can become very heavy, but let's try at least one with our endpoint to see how it's working in our case. So in my case, I can be a little less explicit and just say I want to be able to call the hello if my role I think I have here. No, I have authorities and roles, both of them. That would be fine for me. So if my role is admin, so in this case, this should secure my hello and should allow me to call the hello endpoint only if I have the admin role. So in this case, only if I'm Bill, but not for John. And as you have seen in the beginning, I have started with having the HTTP method, and I have only used the HTTP method with the matcher. So I have configured the access based on the method, and now I have changed a little bit the strategy, and I'm using the path. So I can either use the method, either use the path, either even use both of them combined. For example, I can have both of the parameters here, that would be get in my case, and the path as well. So I can have a situation in which I can specify both on the method and the path what is the access rule, and we can just make it like this to be easier to be seen. So authorize requests for the get hello, you have to be an admin, that would be a role admin, and for any other request you can access it without having any kind of authentication, so without having an user. And again, you can do more and more configuration using the matchers in order to specify in your application which endpoint can be accessed by whom. So hello was my case and Bill was the admin, so that would be, if I call it like this, then I have a 403 which is forbidden, and then I use the other user and I get a 403 as well. So something is wrong probably here with my roles, but generally the idea is that I should be able to call this with the admin role. I think that maybe in this case it's a little bit different on how you use it on global method security and roles, so sometimes I mess it up here. It might be because of this, but I wanted to make you an idea of the configuration itself, so not necessary to configure now something explicitly for this. Okay, no, still not. I'm not sure exactly then what's wrong in my configuration. I will check it later to make sure, but that's the idea in general, to be able to specify who can access what of the endpoints that you configure. Okay, and these are basically the main contracts you are starting from with Spring Security. So just start from this, and in order to get into more details for any of the configurations, and then get into even more details about the architecture like the OAuth flow and the way to use this with JWT tokens and other kind of tokens with all the possibilities of storing the tokens and so on, and the global method security, then you just go to the security playlist that I have in my on the same channel here, and you will find there a lot of videos that I will add, and in which you will find in details how to work with Spring Security. So this is what you should start from. This is what you first need to understand, what a password encoder is, what a user detail service and manager is, and what is the web security configurer adapter and why do we use it. And then starting from here, you can you can just develop your own applications, and all the other videos that you will find on this channel will help you to create your own application and to secure it with Spring Security. Okay, I've finished what I wanted. I won't go any deeper because as I've said, this is a big subject and it takes time, and it's not something that you can discuss in an hour. I wanted just to give you a flavor, and that's what is part of the Spring Framework Fundamentals stream that I have here. Same way I have done with Spring Data, the previous 2 lessons. Don't forget that Spring Data and what we have discussed is only what is related to Spring. But again, for example, if you want to use Spring Data with JPA, then you have to first learn JPA, and then the things that you will learn from the specification, the JPA specification, using an implementation as Hibernate or Eclipse Link, you can then use together with Spring the way we have discussed it in the previous lessons. That's why in the future, in the near future, I'm even planning to start a new JPA fundamental stream that, you know, by using those details we will discuss on the JPA fundamental stream, you can then use them with the Spring Data applications. And then on the Spring Security playlist, I will do the match between Spring Data and Spring Security, which you will actually see it's possible directly from Spring Data to link to the expressions in Spring Security. And that's another very nice thing that you will learn from the Spring Security playlist. And this way, hopefully in the end, I will manage to unify everything and make you understand the best out of the details of this usage of the Spring framework that you will find now in a lot of enterprise applications. Thank you very much for watching the video. Hope this will help you as well. And again, go to that Spring Security playlist for more details, and hope to see you soon for the lesson 14. Thank you very much for watching again. Bye bye.